Oh wow, that is really. Can I go touch that?
Yeah, absolutely.
This is a very, very expensive piece. Is that aluminum or stainless?
That's aluminum.
Aluminum.
Yeah.
And is that fabricated here locally? That's imported.
No, so we buy that from a supplier.
Okay.
And then it's shipped here, comes in through the big door, if you will, and then we machine it down. We're going to remove more than 2/3 of the material while retaining about 90% of the strength.
In certain dimensions, right?
And I will show you that, yeah.
Okay, got it. So this is our raw material, and we're gonna go make a rocket. Okay.
All right.
And so all this is aluminum.
All this is aluminum.
That's a unique dimension. You normally don't see plates of aluminum that wide and that long.
No, so this is actually made especially for us in these dimensions so that we can turn them into the barrel, the propellant tanks of the rocket itself.
Okay, so you're tooling up an entire foundry of some type, or a rolling mill.
A rolling mill.
Okay, gotcha.
So I'm going to show you a couple of different things before we get to the machine. So starting here with the raw stock of 7000 series aluminum, it'll eventually become a round rocket barrel. This is just after machining, and I wanted to point this out to you because this is our old style of grid that we machine in, called an isogrid, and you're familiar with what an isogrid is.
Yes.
Right? So we have isentropic properties when we do the stress analysis, and you can see the triangular patterns in there. That's not actually the ideal pattern for a rocket barrel, but it is what the analytical tools, the finite element analysis tools available to us when we designed Atlas and Delta in the 90s were available to us, and that's why we have that pattern. Vulcan will be better because the tools are better, and you'll see the difference when we walk down the line.
I have never thought about that. So literally, because in the 90s, the FEA analysis could solve a triangle easily.
Yes.
That's why the isogrid is a triangle. I would have never thought that. So basically, if I understand correctly, can I touch this?
Yeah, touch.
I'm going to ask you that every time.
Yep,
So basically,
right.
because you can compute the force coming in one member to a node and the forces coming out the other member, that's how you arrived at isogrid.
Exactly.
Okay, fantastic.
Yeah, it's sort of an interesting thing in the real world, how the engineering tools that are available dictate the kind of designs that we use.